So today we're going to start unit number 2. Unit number 2, one of the big things we're going to be looking at are forces and the effect that forces have on objects. So today I'd like to introduce you to forces. It should be an easy day, but a very, very important day. So don't miss out on any of this. There are 3 terms you're going to need to be able to use in this unit almost all the time. And they are the terms force and mass and weight. So make sure you write down the exact definitions and what these terms refer to. Force is the name for the push or the pull on an object. Anytime we push on an object or pull on an object, that is a force. Forces are measured in newtons, which is abbreviated N. Forces are vectors, meaning you represent them with arrows that have both magnitude and direction. So if I was pushing on this object, I would represent that as an arrow showing the direction I'm pushing as well as how hard I am pushing. So it's a vector because it's an arrow that has both magnitude and direction. Okay? Forces used to be measured in pounds, but most of the world has moved away from pounds, and all of the scientific world has moved away from pounds. So if you run across pounds, which you will in this country, make sure you convert it over to newtons. The next term is the term mass. Mass refers to the amount of matter inside an object. Mass is measured in kilograms. I know that a lot of times in chemistry you worked in grams, but in physics we want to use kilograms, and that is the international standard for mass. Weight is oftentimes confused with mass. Mass just tells you how much matter it contains. Mass is not a vector. Weight, on the other hand, is actually a measure of gravity pulling on the object. So this object has weight because gravity is pulling it down. This weight, this gravity, will change from planet to planet to planet. This mass does not. The amount of kilograms is constant, but the weight is not. Weight, again, is a force, so it should be measured in newtons, and weight is a vector, and it's going to be pointing downward because that's the way that gravitational forces pull. All right? So they are your 3 main terms. Why are forces so important? Well, literally, forces determine everything. So if we're focusing on this soccer ball and we want to figure out what's going to happen, we need to know how much force is applied, both at the corner and when Carly Lloyd hits it in the net with her head. All the motion of the soccer ball can be understood when we look at the forces on the ball. So forces determine everything. Same thing with Donkey Kong. If we want to figure out how quickly he's going to speed up, how quickly he can go around the turn, all of those things depend on forces. So let's talk about forces, and let's focus on the different types you're going to encounter in this unit. For each force type that I show you, make sure you include the name of the force, the symbol for the force, an example, a drawing of an example of that force, a couple of words telling when that force occurs, and telling whether or not it's a push or a pull or both. So let's get rolling. The first force is the force that we see acting between the Earth and Moon. That force is known as force gravity. The symbol we use for gravity is Fg. Gravity occurs anytime you have 2 objects with mass. So all the time, really. Gravity is always a pulling force. Gravity is an attractive force, so it's one object pulling another object towards it. Okay, so that is force gravity. Our next force is force tension. Tension can occur in things like this lanyard, or ropes or strings. It's any time we're using a rope or a string to pull an object. So tension is only a pulling force. You can see tension doesn't work if I try to push. Tension is drawn, just like all forces, with an arrow. It's abbreviated FT for tension. And you can see the rope is pulling down on the helicopter. You can see the rope is pulling up on the basket. You can see the rope is pulling this guy off the roof. And the rope is also pulling the basket toward the roof. Okay? Force tension occurs anytime you have ropes or strings. Next we have buoyancy, which we can see on this little life preserver. Force buoyancy occurs anytime you have an object in a fluid, and force buoyancy is an upward force, and it's a pushing force. The water pushes up on the object, and we call that force buoyancy. We have elastic forces. Anytime we have an object that can stretch or compress. Anytime, really, that you change the shape of an object and it snaps back to its original shape, that's force elastic. Force elastic can be a pulling or a pushing force. And force elastic can act in any direction depending on how the spring or rubber band is set up. Again, force elastic happens when you deform an object and it tries to restore it back to its original shape. It can be a push or it could be a pull. The next one is a force you probably haven't heard of before. But if I put this object down on the desk, there's obviously a force fighting against gravity. And that force is called force normal. Normal means perpendicular. Force normal happens anytime two objects are in contact. So if I take these two objects and clap them together, there's a force normal when they hit. Okay? Anytime two objects touch each other, there is a force normal. Normal tries to push the two surfaces together. Along with that, if the object is trying to move, there will be a force of friction. Okay? Force friction occurs when two objects touch, but it's when they try to slide past each other. So right now there's a force normal, but no friction. Right now there's friction and normal, because the object is moving and friction is trying to stop it. Okay? So in this picture we have two new forces, normal and friction. Normal is a pushing force, and friction you could think is pulling to try and stop it. Finally, what if you don't know the force? We have a person pushing on the Thomas train, and we don't know what to call that force. You can call it force applied. Anytime you don't know the name of a force, use the term force applied. It's a generic stand-in for the actual force. In this case, it's actually force normal because my hand is in contact with the train. Okay, so force applied. I'd like you to practice a few to make sure you can see the different forces. So I have Bart Simpson coming down a railing, and I'd like you to think about what are the forces on him as he slides down. Well, we've got gravity pulling down. We've got friction trying to slow him down. And because his butt is in contact with the railing, there is a force normal. Notice that force normal points perpendicular to the railing. It doesn't point straight up. It doesn't point against gravity. It always points perpendicular to your surfaces. Okay, now we have Homer Simpson on a raft in the ocean, and that's the spot I'd like you to look at. And we're focusing on the raft. What forces do we see? Well, obviously there's gravity. You're always going to have gravity. We're in fluids, so we got a buoyancy pushing up. And we also have Homer Simpson pushing down on the raft. And you could call that force applied or force normal. It's a contact force between him and the raft. We got Homer's car being lifted by the Coast Guard. And if we're focused on the car, we would have only two forces, gravity pulling down and tension pulling up. Finally, we have Homer pulling a vending machine across the nuclear power plant floor. And when he does that, we have gravity pulling it down. We have Homer pulling it to the right. We can call it force applied, because who knows what force that is. We have force normal pushing it up. And as it slides across the floor, we have force friction. Again, this force applied is coming from Homer's muscles. You haven't learned about those type of forces yet, so just call it force applied. The final term we'd like you to know is the term net force, and net just means total. This is what you do if there's more than one force. You try and find the total. How are these forces going to influence the object? We need to know the total of all the forces. You don't just add them up because forces are vectors, so you have to consider direction. So if you focus on this field hockey ball, we see people fighting over the ball and they're all pushing in different directions. So how do we figure out who wins? We find the net force. We have two forces going to the left, so we would add them together. We have one force going to the right, so we would subtract it from these two. Obviously, the net force is going to go to the left. There's a lot more total force pushing left than there is force going to the right. All right, so that is the idea of net force. I hope you understood these terms. We will be using them throughout this unit, and if you're not 100% clear on them, I promise they will become second nature before you know it.